So these are the laws which will be applicable for these sets. One thing is they are logical and you must be already knowing them, and so you need not mug them up. But second thing is, even if you don't know them, and if I'm saying that don't remember them, I'll tell you a method of how to answer them in the exam. So first of all, I'll read them out and then I'll give you a small method using which you can easily answer the questions in the exam. See this. And commutative law, you already know this. So commutative law means if you have AB, if I change the order as BA, that is called as commutative law. So in case of union, it is satisfied, A union B or B union A. Why is it satisfied? Because a set is unordered, so either you include the elements of A then the elements of B, or include the elements of B then the elements of A. Since both are going to be anyway, it is going to be unordered, so it is same. So intersection is also same way, commutative. And then this is nothing but set difference, if you remember, symmetric difference, right? So symmetric difference is also commutative. And next one is associative law. Associative law says that whenever there is an operand and on the other side of the operand there are two operators, which operator you want to associate the operand with, that is called as associative. For example, here there is B in between, and on either sides of B there is union and union. Now do you want to associate B to the first union, or do you want to associate B to the second union? It turns out that in case of union, it doesn't matter. Either it can be left associative or right associative, right? Therefore either you take A union B or B union C first, the ultimate answer, the final answer is not going to change. Therefore union is associative, right? And similarly same thing applies for intersection, and same thing applies for this exclusive OR. And then distributive law. Distributive law says that we can take a operator and distribute it over the other operator. For example, this first equation says that you can take union and distribute it on the intersection. So see this, you can take union inside, A union B intersection A union C, and here you can take intersection into union, which means A intersection B union A intersection C. Got it? And De Morgan's law. So De Morgan's law is there in all the topics, right? So you must be knowing it. A union B whole complement equal to A complement intersection B complement, A intersection B whole complement equal to A complement union B complement, and A minus B union C equal to A minus B union A minus C. It is a kind of distributive law. Minus is distributive over union, and similarly minus is distributive over intersection. As I told you, don't remember them. I'll tell you a method of how to verify whether these laws are right or not. Okay. And next one is idempotent law. Idempotent law says that if you union two sets, you are going to get the same. If you apply union between the same sets, two same sets, then you are going to get the result as same. And if you apply intersection, you are going to get the result as same. And absorption law is generally used to simplify. So see this, A union A intersection B is equal to A. Why is it so? Because already you are having A here, and to A you are adding some part of A itself. If A intersection B, in A intersection B there will be some part which is in A only, right? So already A is there, to which you are adding some part of A. Even if it is 5 also, it is okay. You are adding some part of A, then you are going to get anyway A. Already there is a set to which if you are adding some part of the same set, then ultimate answer will be the same set, isn't it? And A intersection A union B. So what is A intersection A union B is, already there is A, and you are taking complete A and something else. Now if you are applying the intersection, then the intersection will be A itself. It is logical. Even if you don't understand it, I'll tell you a method. Okay. And next one is modular. So this is not very important, but you can have a look at it, you can note it down. And these are some trivial laws. So if you try to apply union with empty set, you are going to get the same set. If you try to apply intersection with empty set, you are not going to get anything, because if nothing is present and if you are trying to find out an intersection with other set, the answer will be nothing, right? And then A union U, this is A union universal set, is going to be universal set. Already A is immersed in U. Now you are taking U and a part of U, and you are applying U union, so then you are going to get the universal set itself. And then A intersection universal set, so you are taking A and then the entire part, and you are applying the intersection, then it will be smaller part, which is nothing but A. And A union A complement, by definition U is nothing but set of everything, right? Now you have A, which means all the elements which are present in A, and A complement, which means all the elements which are not present in A. Then obviously when you join these both, you will get everything, right, which are nothing but set of all elements in the discussion. That is why you get universal set. And then A intersection A complement, so A is nothing but set of all elements which are present in A, and A complement is nothing but set of all elements which are not present in A. There will be nothing in common. That is why it is 5. Okay, now these are all the laws. They are intuitive, you need not remember them, but still if you get confused in the exam if they are giving you an equation and if they are asking you to verify it whether this equation is right or wrong, then take an example and do this like this. See, then you try to construct this Venn diagram. Okay, in this Venn diagram you try to name them first. A, let's say this is A, B, C, and this is U. Let's say this is region 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now assume that these are all the regions, always number them like that. Now whenever any expression is given, take the left hand side and right hand side and you can evaluate it. For example, if you want to see whether this is right or wrong. Okay, now you take the left hand side and you see what is that you get, and then you take the right hand side and you see what is that you get. If both of them agree, then that law must be right. For example, you can take left hand side like this: A union B intersection C. Now what is B intersection C? See this, B and C, B intersection C is nothing but 6, 8, 7, right? What is A? Write like this: A is nothing but A is 2, 3, 6, 8, isn't it? 2, 3, 6, 8 is A. All these 4 regions is A. And what about B intersection C? B intersection C is these two, right? B and C. B intersection C is 8 and 7. Union 8 and 7. Then what is that you got? You got 2, 3, 6, 7, 8. This is A union B intersection C. Now you take the right hand side. What is A union B? A union B, I want intersection A union C. Now what is A first? A union B is nothing but all this, right? So what is it? 2, 3, 4, A union B, 6, 8, 7, 6, 8, 7, right? Intersection A union C. So what is A union C? So these two. So A union C is 2, 3, 6, 8, 5, 7. Now you find out the intersection, then definitely you are going to get 2, 3, 6, 7, 8. Therefore you got the same, so both in the left hand side and right hand side. That is why you can say that both are this law is valid. But then why should we take only this diagram? Because this is a generic diagram. I am taking this as a generic diagram. You can take any diagram and still it should be valid. So most probably you take this one and you try to see it, because it is containing all the areas. So if you take anything like this, then you might see that A intersection B equal to, let's say this is A, this is B, this is C. A intersection C equal to 5, but that condition is not given. So go for the generic condition. Here all the areas are present. There is an area with A intersection B, there is an area with A intersection C, and there is an area with A intersection B intersection C. All the areas are present, no area is null. So it is better that whenever nothing is given, you take this particular diagram and then try to evaluate them. So if you try to write all the numbers and try to evaluate what is in the left hand side and right hand side, you will be easily able to guess whether a law is right or wrong. For this you need not remember it. Okay, so even if you want to see about De Morgan's law, A and B, you can take some diagram like this: A, B, 1, 2, 3, 4. Write all the regions. The outside region is 1, and this region is, A minus B is 2, A intersection B is 3, B minus A is 4. Let's say this is A and this is B, right? And now what is A union B? A union B is 2, 3, 4, isn't it? And what is complement? Complement is union minus that entire thing. What is union here? Universal set minus this entire thing. What is universal set here? 1, 2, 3, 4. Therefore, from 1, 2, 3, 4 you subtract 2, 3, 4. Then what do we get? 1. Therefore, left hand side is 1. And similarly, you can find out A complement. What will be A complement? Whatever is not present in A. So what is it? 1, 4. And what is B complement? Whatever is not present in B, which is 1, 2. Now you take the intersection of these two, which is nothing but 1. So this is how we can verify any equation, any law in general. Okay, so don't by heart any of these laws. I just wanted to show that these laws, they exist. Okay, I didn't mean that you have to mug them up. Anyway, note them down and just let them be in your notes. Just revise them. If you can remember them directly, you can answer them in the exam. Otherwise, use this method. My suggestion, don't remember anything. Try to derive everything in the exam. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.